it has been a nice day hearing a lot about energy efficiency, about the opportunities that we have for supermarkets. I will try just to frame a bit all the things from the Danfoss eyes perspective. The agenda will be basically, let's understand what are the challenges that you supermarkets or C-stores owners have. What are the challenges coming from several perspectives? Then how to turn those challenges into opportunities. And then let's see what is the potential, where we can start, how to start, holistic approach on ABCD plan, let's say, because we have seen a lot of opportunities that in fact we do have, but probably you could be asking yourself, how can I start? I mean, I have a 10-year supermarket, or a 7 or a 5, or I'm going to build a new supermarket, and what shall I do? How shall I make my first moves? So here we go. Let's first of all try to understand what is the real demand that we have from the customers, because the reason of having a supermarket or a C-store, it is the customers that we are going to serve and the way we do it. So today, especially after COVID, we are facing heavy and bigger demands from the consumer. Example, consumers want fresher food and they need it clean, and then probably they want now much more variety of the food, and in the top of that they need that those descriptions to be cheaper food than before, and then probably they want that the supermarket becomes smaller so they don't mix with other people, especially now during these events, and they want it close to their houses so they don't have to drive long distances for the timing, for example, when we had those limitations on movements. And probably they also, if they want to walk to the supermarket, or if they want to drive to the supermarket, then probably they want to have a parking lot, and then they want to have an electric machine to charge their car in case they are driving an electric car. So a lot of demands are coming now from the users. And this is for sure coming in the top of the costs of the operation of the supermarket. Reducing a supermarket, putting it into a neighborhood, it is expensive. The cost of lands, the cost of spaces in the neighborhoods are expensive. So how to make this thing profitable? Then we have the new technology. And the new technology, we used to have supermarkets with on-off systems, like we saw in the examples that my colleagues were speaking before. You need a simple technicians. He will be able to change a product, to move it on, replace. It was a simple thing. Today we have a lot of electronic components there. So how to operate electronic things? Now we start to have challenges with the technical support that we have. The quality or the specification of a technician are becoming higher and higher. And some of the countries are starting to struggle on that capabilities of technicians. So high skilled technicians, engineers are becoming less and less. So the amount of information going towards there, it is something that it's been improved and increased these days. But how much or how fast they are getting into that. So the technology is becoming a barrier when it is related to the technical support right now. Apart that technology, most of the time becomes a high cost at the beginning, CapEx. And then all these two things are for sure hitting the margins. Historically, supermarkets run in very low margins, their business is volume. And here we are talking about how to improve costs in order to keep doing that small margin, because this is at the end the reason of the business that we have. So, and to combine all the things and make it funnier, then we have the authorities. Then we have the municipality, the customs, the health authorities, making the rules much more strong and created sometimes some uncertainties, HACCP reports, monitoring systems. So a lot of things that we are struggling today, that if we start taking them one by one, we can convert them in opportunities, and then we can make our life easier. Example, we can start thinking on optimizing the food safety. So to optimize the food safety, we will be compliant with the customers that they want fresher food and better quality of the food. We will be engaged with technology and making the use of the technology that it is coming right now. We have a lot of technology in our supermarkets. We are generating a lot of data. We always did it, but we never digested. So here it is the second point coming, thinking ahead with the big data. So now we can make that data to speak to us. The data is the voice of the supermarkets, of the C-store. We never heard it before. We were just tackling the troubles as they were coming. So now we are able to hear that data and to understand what the supermarket is suffering or what are the opportunities that we have, and the supermarket is telling us to enhance. So here it is the moment to start understanding technology and getting the maximum use of the actual technology that you guys have in the supermarkets right now. And then the climate change. We cannot avoid thinking on climate change. And we can see it in several perspectives. First of all, to be responsible, we need to contribute. This is a reality, people, and we need to understand that we have to put our foot into that and take actions, especially when we acknowledge that supermarkets are responsible for 2% of the global electricity consumption. So if we think on climate change as part of responsibility, we can also take it as the marketing strategy, let's say, because we, the end user, we would like to purchase our goods in supermarkets that we know they are contributing to the enhancing of this world. So being also compatible or compliant with the climate change, it's a positive marketing tool that we can use. So it's the time to use and talk efficiency, food safety, because this is what really manages the climate change. And at the end, maximizing the energy efficiency. Energy, it is probably, let's say, regularly cheap. It used to be cheaper, far cheaper before. It will become very expensive. So it is time. So it's time now to think how to use it properly and make use of it. We consume energy to produce something. How we can get more profit and more things out of the same energy that we are consuming. So here it will go. Here it comes. And the story starts making you think that the actual supermarket that you have is able to save 50% of the energy that it's consuming today, okay? And the supermarket that you want to build tomorrow, you can make it from now 50% more efficient rather than a standard supermarket that you do. And that 50% of energy saving, it means 60% of CO2 reduction. And this is where the climate thing comes. So automatically, if you are adjusting to an energy saving ideology, let's say, you are adjusting as well your footprint on carbon emissions. So you are being compliant. And also your supermarket can be surveilled 24/7, ensuring that this 50% of energy saving, it has been there, you are not going off track, and you are having this contribution to the world with that 60% of reduction of CO2 emissions. Plus, you will have surveillance of all your systems, like all the colleagues have said before, with all the advantages that the colleagues said before. So this thing, it is a reality, people. It is the supermarkets that you are handling or planning to open or expanding. You have that today. So how we think on the next move? Today, most of the supermarkets are kind of standalone, are disparate. So we have the refrigeration system working here, air conditioning system working here, lighting here, energy management somewhere there, water consumption somewhere there. We need to connect all these systems, because as one of the explanation done by our colleague on the efficiency on the funds, that you cannot touch only one part because it will affect potentially negative the rest. The same will happen here. So if we want to enhance the refrigeration system, but we don't touch the rest, we are losing a lot of potential of energy saving. So if we connect all the systems of our supermarket, including our logistics in the supermarket, we can decide which is the perfect timing to load and offload in our supermarket, which is the perfect timing to load or offload our cold rooms, depending on the perfect timing or when the energy it is cheaper or when the number of people is less. So this efficiency, it is not only in the energy consumption, but also in the operation. It opens you the portfolio to be efficient even in the operation of your supermarket. So here is where we need to open our eyes and let the technology help us and work with us. The technology is the only one able to read the data and translate it in facts. We only need to connect dots and say what we want as an outcome. And this is the way we start enhancing and retrofitting supermarkets. And let's say the way of doing it, it is exactly the same as we have today. The companies like EPTA and other contractors, they start doing diagnostics in your existing supermarkets. What do you have today? Then they draw a potential. If we do this, we can save that. If we do that, we can save that. Then you guys sit together just to decide the impact of these changes, cost plus the timing and the operation of the supermarket. Then the implementation starts step by step. And then you start looking at the results in your smart data management that you are going to have. And after that, it is a cycle. As soon as you see that it is giving you responses, positive outcome, then you can keep adding and adding and enhancing and enhancing. It's a simple 1 to 3 steps. So in Danfoss, we have drawn, let's say, basics of how to start doing it in supermarkets. And let me jump straight forward onto that. So suppose that you have a C-store right now, or a supermarket or a hypermarket. And then you decide that I am not efficient and I want to do something. So you could start in the basic level 1, which is monitoring and management of alarms. Simple. We are expecting that most of the cabinets, they have a small electronic controller able to send basic information about temperature, defrost, and this thing. You might start making use of the management system that you have. And then simply analyze the alarms that are coming, some sensors probably for doors and things, just to start educating yourself of what kind of supermarket I have, where are the alarms coming from, and how I can improve my supermarkets only looking at alarms. It is a cooperation with contractors. It is a minor, let's say, investment. It is also a modest saving, not the big one. In case you want to think ahead, then we can start talking about adaptive systems. And here it is where we start thinking, okay, I want to do a major job and I want to see more efficiency. I am willing to pay a bit more, even though I am going to recover those investments in X period. And this is the job of the contractors, to tell you for this investment, this is the saving. Your ROI or recovery of the investment is going to be in 1 year, 1.2 years, things like that. And then you take the decision. So level 2, it is where we start thinking about electronics expansion valves, where we start thinking about EC fans, like we just heard, frequency converter in the rack systems to start manipulating the compressors, and frequency converter probably in the condensers, because if you start touching the condenser, then you are optimizing, you are able to reduce the speed of your compressor. If you are analyzing all the pressure of your cabinets, you can balance them. And then the entire pressure of the system can be dropped in something called the floating suction or pressure. And here is where the major saving is coming. So level number 2, it is where it is a major work, but where the major saving it is coming in a first jump, let's say. And then you will have a balanced system. Once you have a balanced system, then you can start fitting here, tweaking here and there to enhance more and more. But here you will end with a supermarket with a monitoring system, with a fancy, very organized and balanced refrigeration and air conditioning system. Then the next level, it is where we start thinking about compliance. And here is where we think about especially CO2. Here we want to migrate from the HFCs to the natural refrigerants. Natural refrigerant, as was explained at the first presentation by Andrea, they are already energy saving. So if in the top of level 2 you add refrigerant, you will start adding more savings in your system because you need the same controls that you already have. But changing, migrating all your system to CO2, it is definitely climate change compliance. We will be forced by the authorities to move sooner or later to these technologies, and you will keep adding on the savings as well. And then level 4, it is where we start thinking on big in our shop. It is where we want now to integrate the air conditioning, for example, to the same pack that we have for the refrigeration. And then we want to integrate as well the lighting. We want to integrate an energy management system, something that tells you your energy is going here, there, there. And then the system will tell you how to optimize your processes to make them when the consumption it is slower. So you don't consume or waste energy. And this is one of the smartest things. And then the 5th level, it is where we become a supplier. So until the level 4, we are a simple consumer of energy. We absorb electricity and we generate cool. We generate chilled air, we generate chilled water. And then what we can do with all these things. So a CO2 system especially, or a normal refrigeration system, they generate a lot of heat. So in the Nordic countries where you have to have a heating distribution plant, you pay for hot water to cool the floor and to make your store warm. In our region, we don't need that, but we need hot water in a supermarket. Or imagine that it's a C-store that is in a pump station. We need hot water for the car wash, if they have a car wash, or for the normal cleaning of the pump station. If the supermarket is in a building, that building needs hot water. And then here is where we start using the same electricity that we are consuming in our pack and using the extras that are coming. So we don't waste the heat is the first thing. So we can absorb that heat, transform it in hot water. We can avoid boilers. We can avoid heaters. We can have our own water for internal processing in the hypermarkets, for example, that they prepare food and they might have a lot of hot water use. Or in the C-stores, as I said, in the buildings, in the pump stations. So hot water is the first thing. And then the system could be so efficient that it is always cooling. So we could absorb that extra cooling that we can generate when the energy rate probably it is cheaper. And we can generate ice, and we can start working with ice banks. So we can pre-cool things before we put them in the cold room, and we don't spike the loads in the cold rooms. And anyhow, we are generating ice, we are producing ice. So we are avoiding those spikes in the cold rooms. We are saving electricity in that way. Or the third thing, if we have a standalone supermarket with a parking lot and we transform all the roof in photovoltaic cells, we are generating electricity. And this is something happening now in Dubai. A lot of the energy is coming from photovoltaic. They want to move forward to 30% of all the electricity coming photovoltaic. So they will open the chance for you to, if you are able to produce energy, you consume from your own energy. And if you have a surplus, you can simply sell it to the grid. So a lot of opportunities we have in our supermarket, of course, depending on which level we want to position ourselves. And the next slides, I want to rush on them, don't want to take much time. It is some examples, as all the colleagues show. So in the level 1, in the monitoring and management, theoretically, you can save from 5 to 10% the energy. Only reading the alarms and taking actions. The door is open. The electric consumption of that cabinet is going up, check the fans. The electric defrost are all coming at the same time. It doesn't make sense to have that peaks. Only on level 1. If we move to level 2, it is where theoretically you can do from 11 to 20%. But in the examples that you will see, we have real cases where we are saving 33%. The same on the level 1. You might saw something between 20 and 29% of the example that we have. So this is the theory that components in the perfect case or in a new system will save. And this is the reality when we already have a supermarket that has been running and we have some defects on installations probably. So this is one of the best case scenarios. We can save up to 20%. My experience of 15 years in Danfoss and upgrading supermarkets in South America, changing towards expansion valves, adapting the pressure of the entire system, it is blindly given the 20%, blindly. And then if we move to the level 3 that I said, natural refrigerants, here is where I want you to focus. There has been a lot of rumors, and actually you, Marcus, were asking about the efficiency of the systems. When CO2 started, it was a booster system. It was extremely expensive, and electric consumption was something too much. Versus a R404 system, it was 11% higher on electric consumption. So it was more to the natural thing rather than to the efficiency. But then the technology has been changing, and you asked how likely it is to use those systems here. Yes, a booster was not good to use in hot climates, but then parallel compression started, which is the sort of cascaded systems and subcoolings and all these things. And then we started to see some enhancing on the energy consumption. And in the second column, you will see now the comparison with the initial system, which was the booster. So you will see parallel consumption versus the booster. It is already saving some energy there. And I'm not able to see this, 15%. And then the technology started with the ejectors. Danfoss was part of the people developing ejectors. And then the first one was the gas ejector, which was fairly good compared to the initial system, 18% more efficient. But the liquid line was still highly pressured in the systems. And then the liquid and gas ejectors came to life. And this is the latest technology, which is far better because we are using the same pressure of the system to keep the pressure on the injection. So we don't need second stages. We are reducing the size of the system. Yes, it generates more heat, but we need that heat, as I said before. We need to heat water. We need to heat the floors. We need to heat the buildings or the pump stations where we are. So this is CO2, people. This CO2 came to save the world because whatever leakage, even the charge is lower, but whatever leakage we have, it is fine. We are not harming anyone, and will be easier to find in the market. The prices of CO2 equipment solutions are coming down. The challenge is the pressure, which is very high, but now components are becoming much more efficient, and as the volume is increasing, the cost of components are reduced, and then the sales prices is become better. And the brands are nameless. You can name the brands. Everyone is producing materials and equipment and solutions for CO2. Think on CO2, it is coming sooner or later. We cannot avoid it, as simple as that. And then we have up to 22% saving, and this is what I was saying. If you already have a level 2 supermarket and you migrate to CO2, you can add 10% in the top of that. Once we start integrating in the level 4 with the use of ejectors and all the HVAC systems, and then we start to integrate all things, we start to see a bigger, let's say, efficiency, because now we are talking about the HVAC system, which represents 20 to 30% alone of the consumption of the supermarket. So if we integrate to this already efficient packs, then we are basically canceling the consumption of the HVAC system. So it is something still in study and in deployment, and people and the manufacturers of systems, especially of supermarket systems, are still discovering and on-taping solutions for that. So what is these things in the level 5 that we can do? If we start, this is our system. We have a compressor rack that is generating a lot of heat, and today we are simply wasting that heat, even putting some fans to extract the heat from the rack room, let's say. So then we have for the Nordic countries that have the district heating systems, we could start supplying hot water to the grid, but also for the internal use of the supermarkets, we can start using it. And then also we have the storage of the hot water or the ice that I was discovering in the other side. So here we started to be a supplier, because we start to supply hot water, we start to supply ice. And then the electricity part, that if we work with renewable energies, especially in the nice sun that we have almost all the year, then we can become electricity supply. So we consume from our own electricity, and the surplus we can sell it. So we can convert our supermarkets, as I said, a bigger business. Not only, example like Mark and Spencer, that they were a department shop and they discovered that being a food supplier, it was making more sense. Supermarket can have the same transition as well. They can become a real industrial generating heat, ice, and electricity. So this is basically what I wanted to show you as a holistic view of the potential that we have in our supermarket. Technologies are everywhere. We need to acknowledge that any supermarket, anyone, from the convenience stores that we have in the metro station till the hypermarkets that we have very far just because they need big space, all of them, they have endless opportunities of enhancing. Cold stores are, like we were seeing, all the opportunities that we have with airport times and so on, also a bigger potential for consumption. Go electronics, there are plenty of brands and technologies. We need to accept that the technology, it is moving us, and we cannot simply escape from it. I'm Alexander Abrass, head the cooling segment for the Turkey, Middle East, and Africa, and we are here to help you. Thank you very much.